Hey guys, this is Mr. Mood. Today we're going to talk about polynomials. At the end of this lesson, you'll be able to multiply parentheses together using the distributive property. So let's first talk about polynomials. What is a polynomial? Well, a polynomial is an expression that has more than one term. And here are three different cases we're going to talk about. We got a monomial, which means it has exactly one term. Now it'll look like this, something like 3x squared. Then you got a binomial, which means it's got exactly two terms, so 3x squared plus 5x. And then a trinomial has 3, so 3x squared plus 5x minus 2. Polynomials can get as big as you want. You could have 100 things inside the polynomial, but here are three very specific cases that you're going to be expected to know this year. So let's get down to business. What I told you before is that we want to learn how to multiply parentheses together. And as you see here, we have two parentheses. We're going to use distributive property like we already learned how to do in a previous video. And here's how it's going to work. We're going to take the first term inside of the first parentheses and we're going to distribute it to everything inside of the second parentheses. So 3x will be multiplied by 2x and 3x will be multiplied by positive 1. Let's simplify that before we go on. So 3x times 2x is 6x squared, and 3x times 1 is just 3x. Then I take the second term inside of the first parentheses and I multiply it by everything inside of the second parentheses. So in this case, I've got negative 5 times 2x and negative 5 times 1. Simplifying that, I get negative 10x and negative 5. Now I simplify the expression, so that means I have to identify and then combine the like terms. So looking at this expression, I only see two terms that are in the same family. That's the 3x and the negative 10x. So I combine those, I get negative 7x. Once I've combined, I bring down the rest, so 6x squared and negative 5 come down. I rewrite it so that I don't have any more parentheses. My final expression is 6x squared minus 7x minus 5. Now this kind of happened by chance, but whenever you're finishing up your expression, you're putting it together in the end, you have to do it in a very specific order. As you kind of notice, my polynomials, my terms inside of my polynomial, go from the biggest power to the smallest. So the 6x squared has a power of 2, the 7x has a power of 1, and then the 5 has a power of 0. So it goes from 2, 1, and 0 in order of the powers. So in this polynomial, I've got 3 terms inside of the first parentheses and 2 inside of the second. So this works just like I did before. I take every term inside of the first parentheses, multiply by every term inside of the second. So we start with a 3. 3 times negative 6 and 3 times negative 5. When I do that, I get negative 18x plus negative 15. Then I do the same thing for the negative 4x. Negative 4 times negative 6x. Negative 4x times negative 5. I get 24x squared and positive 20. Then I have to do the same thing for the x squared. So 1x squared times negative 6x and 1x squared times negative 5. I simplify that. Negative 6x to the third plus negative 5x squared. Now I identify all my like terms and I combine them. So looking at this expression, I see I've got two sets of like terms. I've got negative 18x and positive 20x. I've also got 24x squared and negative 5x squared. So I start by combining the x family. I get 2x. Then I combine the x squared family and I get positive 19x. I bring down the remaining terms in the negative 15 and the negative 6x to the third. Now I take my terms as they are and I rearrange them so I go from the highest power to the lowest, and that looks like the bottom expression, negative 6x to the third plus 19x squared plus 2x minus 15. So let's wrap this up. When we're multiplying polynomials together, you distribute each term inside of the first parentheses to every term inside of the second parentheses by multiplication. Then you take the terms you got, you combine any like terms, bring down the remaining terms. Once there are no more like terms, you rearrange them from biggest power to smallest power, and then you're done.
That's all, folks.